Hello everyone, my name is Pragati Kapoor. I am presenting my project what I worked on during my internship at Emertxe. During this internship, I worked on a home automation system under the IoT domain. The main objective of this project was to design and implement a system that allows users to control home appliances remotely using IoT technology. Through this internship, I gained a practical experience in embedded systems, IoT concepts, and real time project development, which helped me strengthen my technical and problem solving skills. So, our program started with introduction to IoT and embedded system. So, let's look into what is IoT. IoT, or that means Internet of Things. The Internet of Things refers to a network of physical devices that are connected to the network and can collect, share, and exchange data. These devices, often called smart devices or connected devices, can include everyday objects like sensors, home appliances, vehicles, industrial machines, and wearable gadgets. The main components are, as I said, sensors and devices. These collect the real world data. Connectivity transmits data using Wi Fi, Bluetooth, Zigbee, or cellular networks. Data processing, cloud or edge computing systems. User interface displays information or allows users to control devices through apps or dashboards. So, in our project, we basically used Blynk IoT app and for user interface. Yeah, that's it. So now let's look into what is embedded system. An embedded system, as we all know, it is the combination of software and hardware. Is a special purpose of computer system designed to perform specific task or set of tasks with larger systems. Unlike general purpose computers, embedded systems are dedicated to one function and are often built into devices we use daily. The main components under embedded systems are microcontroller or microprocessor acts as the brain of the system, memory which stores program code and data, input and output interface connect sensors and actuators, and the software that is firmware. The hardware which we used in our project is Arduino, and we used a software called as PiximLab. Yeah, so here, while implementing our project, we basically used three main softwares: Arduino IDE, PiximLab, and Blynk IoT mobile app. So Arduino IDE, it is basically used for programming, and the main purpose is to write and upload the code, Arduino code, that to in .ini file. The code includes logic for controlling appliances like LED lights and temperature sensors and inlet and outlet valves of water tank. Communication with Blynk app through Ethernet, reading sensor data like temperature, LDR, etc. Then we uploaded this code to the microcontroller in simulation to PiximLab. So in PiximLab, which is the simulation part, it simulates the hardware setup virtually. You can connect Arduino board sensors, LDR, temperature sensors, etc. Output devices, LED relays. PiximLab reads the program you wrote in the Arduino IDE and runs it like real hardware. So the Arduino ID file, while verifying it, we just compiled it from into the hex file. Here in PiximLab, we load that hex file to run the hardware parts. Next is Blynk IoT app. It is a mobile app, and the main purpose here is it acts as the user interface on your smartphone. We can create buttons, gauges, and display in the app to turn on and off the appliances, monitor sensor readings. Blynk communicates with Arduino through Ethernet. Just by using those widgets or buttons, we can where the button acts as a switches, we can on and off, we can control the whole project within that single IoT app. The example here is when you tap a button in Blynk, it sends a signal via Ethernet to Arduino. In Pixim Lab, the Arduino receives it, it executes the command, and the command example turn on the LED. So the project requirements, the home automation should be stimulated on the Pixim Lab simulator, Blynk IoT mobile app. These are used to control the devices, as I already said you. Here we basically control the garden lights, temperature of the home, inflow and outflow of the water in the water tank. When you can see in the image, there is a Arduino ID of Pixim Lab and Ethernet is also present. Ethernet acts as a connection between the app and the board. We can even use the Wi-Fi. So here we used Ethernet. Garden lights. The input here is the LDR sensor. Process is it reads the LDR sensor value. Based on the reading from LDR, vary the brightness of the LED, which resembles controlling garden lights based on the availability of sunlight. If there is more sunlight, we don't require the LED light, so it won't be turned on. In absence of sunlight, that is during night, the garden light will glow, and the output here is LED will glow. Next comes the temperature control system. Here we are having heater control and cooler control. The temperature control system consists of heating resistor, an LM35 temperature sensor, and a cooler, which resembles the temperature control system at home. It reads the temperature from the temperature sensor, that is LM35, and display it on the CLCD. CLCD is like we will come through it in our further slides. Control the temperature of the system by turning on and off the heater and cooler through the Blynk IoT mobile app. The first agenda is to display the temperature on gauge widget and CLCD. Here the input is temperature sensor. It reads the temperature from the temperature sensor and it displays on the CLCD and even the gauge widget. Next comes the cooler control system. Here the input is of course the button widget, which is present on the Blynk IoT app. Process is to detect the change in the logic level, like how much what is the temperature and all such things. Output is if the button widget is at logic high, then turn on the cooler. If the button widget is at the logic low, then turn off the cooler. Heater control system. Here it is same, the button widget is present in the Blynk IoT app. Process is to detect the change in the logic level. If the button widget is at logic high, turn on the heater. If the button widget is at logic low, turn off the heater. And the last control system of this temperature sensor is threshold temperature control, where it says that we should read and compare the temperature with a certain threshold. Here our threshold is 35 degrees. If the temperature is more than 35 degrees, then we should turn off the heater and send notification to Blynk IoT app and display the same on the CLCD. This is what we do in the threshold temperature control system. The next and the last part of our implementation is inlet and outlet valve control. Read the volume of the water in the tank through serial communication and display it on the CLCD. Control the volume of the water in the tank by controlling the inlet and outlet valve by sending commands through serial communication. Display the volume of water in the tank on the CLCD. Here, the first main thing is to display the volume of water. Input a serial tank. Process. It reads the volume of the water in the tank by sending commands through serial communication. Output is it displays the volume of the water on the gauge widget as well as it displays the volume of water on CLCD. The second need is inlet valve control. Input is a button widget as usual on the Blynk IoT app. Process to detect the change in the logic level. Here the output is if the button widget is at logic high, turn on the inlet valve by sending commands through serial communication. If the button widget is at logic low, turn off the inlet valve by sending commands through serial communication. Outlet valve control. Input is as same as inlet valve, that is on button widget in on Blynk IoT app. Process is to detect the change in the logic level, whether the water flow is high or low. Output is if the button widget is at logic high, turn on the outlet valve by sending commands through serial communication. If the button widget is at logic low, turn off the outlet valve by sending commands through serial communication. Next is the control the volume of water in the tank. Input is serial tank. Process it is as same as we did the threshold temperature. There our threshold value was 35 degrees Celsius. Here our threshold value is less than 2000 liters. Process the process over here is reads the volume of the water in the tank by sending commands through serial communication. If the volume of water in the tank is less than 2000 liter, then it turns on the inlet valve and send notification to Blynk mobile app and display the same on CLCD. Here in this slide, I have added the screenshot of the code which I wrote and compiled it, and there was zero error. So now let's look into how we created buttons or widgets in Blynk IoT. First of all, we should browse Blynk Cloud and create an account. And then after creating an account, we should create our own new template. So I made it in the name of Home Automation. And then we should go to Developer Zone and add data streams. Here the data streams we used are heater, cooler, temperature, volume, inlet valve and outlet valve. So we should give the pins necessary for heater. It is V0, temperature V1, cooler V2, volume V3, inlet valve V4, outlet valve V5. Except for temperature and volume, rest all are the buttons we used. For temperature and volume, we used gauge, uh, where it is used for controlling. And in the next slide, I have just added a screenshot where you can see the LEDs glow, and even the CLCD is showing the temperature which we had set. It was basically we set it at 27.34 degrees Celsius. So yeah, that's it. In the next slides, next in the next part of the video, I'll be showing you the simulation. Yeah, thank you. Well, here we can see that as we decrease, as there is no sunlight, the LED turns off, and as there is less sunlight, the LED turns on. And even you can see that this LCD is displaying the temperature. So this was the first part of the simulation which we worked on. Well, after loading the hex file, we can see that the heater, the temperature is increasing. So the heater is on, and later after it reaches, the cooler gets on, cooler is off. It is all controlled through the widget, Blynk IoT app. So once the heater reaches 35 degree Celsius, when the temperature reaches 35 degrees Celsius, the heater gets automatically off. So this was the basic implementation what we thought of. After loading the code for serial tank, we can see that the water level in serial tank is increasing gradually, and that is called the inflow. We can on and off the inlet valve by using our Blynk IoT app, and the volume will be displayed in the gauge widget. If the volume of water is less than 2000 liter, then inlet valve will turn on. And the maximum volume we set for the gauge is 3000. So yeah, it is basically up to 3000. Well, that's it. This is how we implemented the project. During the course of my internship, working on the IoT based home automation project has been a highly enriching experience. This project helped me gain in depth practical knowledge about the Internet of Things, sensor integration, microcontrollers, and real time data communication. How to use the Blynk IoT software, even Pixim Lab. I gained valuable practical knowledge and hands on experience in integrating both hardware and software components. I learned how to design, develop, and implement a system that enhances convenience and energy efficiency through smart automation. I would like to sincerely thank my internship guide, mentors, and the entire organization for providing me with this valuable opportunity, continuous guidance, and encouragement throughout the project. Their support and insights have helped me strengthen my skills, confidence to take up future challenges in the field of IoT and embedded systems. Thank you once again.